Okay, looking at our Chapter 9 review here, this very first section is converting or plotting polar coordinates. Um, so here's some points and directions are to graph them, and then find a couple of other polar coordinates that plot the same point but have a different theta and r. Remember that your polar coordinates, even though that looks like an xy, that is actually an r and a theta. This is an r and a theta, where you first find the angle theta, which 0 is right here, and r tells you how far to march out in that direction. So I'm going to go out to 3 units, and there's our point for number 1, and that's part A. So I've done part A. Then it says find a pair of polar coordinates that plot the same point but have a different angle. Um, Now this one's kind of an interesting one. Um, because both of the angles are actually labeled right here. You have 0 or 2 pi. So for part B on number 1 is actually going to be kind of easy because the angle 0 radians is the same as the angle 2 pi radians. So that would be a polar coordinate that has a different angle. Um, you could also do 3 and negative 2 pi. That would actually go all the way around the circle in the opposite direction. Instead of going all the way around counterclockwise, if we went around clockwise, that would be a negative 2 pi angle. Part C, find a polar coordinates that plot the same point but have a different r. Well, the only different r you could possibly have is negative 3. Your distance from the origin is either going to be 3 or negative 3. And if my distance is negative 3, that means we are running away from an angle. And this is negative 3. We are running away from the angle pi. So that would be your answer for um, number C. Uh, by the way, for part B, you really only have to give one. I just put 2 there just for the sake of putting 2. Let's see, number 2, we have the angle, or r is 2, and the angle is pi over 6. So I will start by finding my angle pi over 6. And if r is 2, that means I need to march out 2 units in that direction. So I'll go out 2 units. There's my point. So part A is done. And then part B says to find a polar coordinate that plots the same point with a different angle. And probably the easiest way to get the different angle would be to go all the way around the circle one more time. So what I could do, if you want an algebraic way of doing it, instead of just kind of fuzzying your way around the circle, I started at pi over 6. If I add the entire circle, that will give me a new angle that's actually the same place, but it's going to look different. Uh, when you add pi over 6 and 2 pi, you've got to get a common denominator, so we'll change 2 pi into 12 pi over 6. And pi over 6 plus 2 pi is 13 pi over 6. So my answer for part B would be a distance of 2 in the direction of 13 pi over 6. And there are other options. You could also have subtracted 2 pi instead of adding 2 pi, but either one. Part C is same point but a different r. Well, if my r was positive 2, the only other possible different r I could use is negative 2. And negative 2 means you're running away from an angle. Now, when you look on the opposite side of the circle, the denominator stays the same when you go straight through. So I'm going to look at the other over 6 angle. And in this case, the one in the third quadrant is 7 pi over 6. So it's going to be negative 2 and negative 7 pi over, or positive 7 pi over 6. There we go. Let's look at a couple of others. Negative 4 pi over 3. Well, first I'll find my angle, pi over 3. That's right here. And negative 4 means we're going to run away from the angle. So I'm going to run away from pi over 3. And if you run away from pi over 3, you're going to go to the other over 3 angle down here. That would be 4 pi over 3. So I'm going to go down or towards 4 pi over 3, 4 units. So there's part A. And part B, I'm going to do the same thing I just did on that last one. I'm simply going to add 2 pi to pi over 3. So pi over 3 plus 2 pi, which is the same as 12 pi over 6. I'm sorry, no, 2 pi, if you put that over 3, that's the same as 6 pi over 3. Got to get a common denominator. And pi over 3 plus 6 pi over 3 is 7 pi over 3. So one answer would be negative 4 and the angle 7 pi over 3. No, I'm not changing my r, I'm only changing the angle. You could also, if you wanted to, I said this on the last one, you could subtract 2 pi minus 2 pi, which is 6 over 3. And 1 pi minus 6 pi is negative 5 pi over 3. So you could also have negative 4, negative 5 pi over 3. So those are both acceptable answers for part B. Part C, a different R means I'm going to have to do the opposite of this one. So if it was negative 4, I'm going to have to do positive 4. And positive 4 means we're running, that's the angle we're running towards, and we're actually running towards 4 pi over 3. So 4 pi over 3. Good. All right, number 4 here. 1, negative 5 pi over 6. The way I find a negative angle, the easiest way for me is I'll find the positive one. So here is positive 5 pi over 6. Negative 5 pi over 6 is going to be straight below it. So I'm going to look straight down, and the denominator will stay the same. And I'm going to go straight down to 7 pi over 6. So that's how I'm going to find my angle negative 5 pi over 6. And we're going 1 unit in the direction of negative 5 pi over 6, which is right here, very close to the origin. So there's the graph and a different theta. I'm going to do exactly what I've been doing. I'm just going to take my angle, negative 5 pi over 6, and I'm going to add 2 pi, which is the same as 12 pi over 6. And that gives you 7 pi over 6. So my answer for part B is going to be, I'm going 1 unit in the direction of 7 pi over 6. And that one was kind of silly for me to do the math, because I could have just looked at the graph and saw that I'm moving towards 7 pi over 6. So there's my answer for B. And part C, a different R. Well, if my original R was 1, I've got to go with negative 1. And I'm running away from the angle pi over 6. So you look for the angle that has the same denominator on the opposite side of the origin. So I think that's all of it for this one. Nope, one more. By the way, there are multiple answers. There are many different answers for B and C. I'm just giving y'all, in this case, I just gave you one for each. And number 3 here actually gave you 2 options for B. All I'm asking for is 1. Okay, let's see. Negative 3, negative 4 pi over 3. So let's see, negative 4 pi over 3. I would find positive 4 pi over 3. Here's positive 4 pi over 3. Negative 4 pi over 3 is going to be the angle straight above it with the same denominator. So there's my negative 4 pi over 3. Whoops. So negative 4 pi over 3 is right here. And I'm going negative 3, which means I'm running away from it. So I need to find the angle in the opposite side of the circle with the same denominator. So something over 3, which is 5 pi over 3. And I want to move away from 2 pi over 3, which is towards 5 pi over 3. 3 units. So 1, 2, 3. There's my graph. Same point, but a different angle, a different theta. Well, I'm just going to look at my graph this time. I can tell that I moved 3. Actually, I don't want to do that. Wait, never mind. I ran away from 2 pi over 3. So if I want to keep the same R, but choose a different angle, negative 4 pi over 3 and 2 pi over 3 are the same thing. And so there is my answer for B. There are other options, but that's the one I'm going to go with. And part C, I'm going to skip the math for this one also. If I want a different angle, or a different R, that would be positive 3. And I'm moving towards the angle of 5 pi over 3. A positive R tells you you move towards the angle. A negative R means you're running away from. I think that is all. Yep. Okay, so there is section A on the review.